students, in the last class we studied about some important points on the chapter mechanical properties of solid. So here there are some important numericals on this chapter. You can see the first numerical. Each numerical carries 5 marks, and the numericals are very important part of the physics. So see the first part, first numericals. What is the percentage? What is the percentage? What is the percentage increase in length of increase in length of increase in length of increase in length of a wire of diameter of diameter of diameter 10.5 millimeter stretched by a weight by a weight stretched by a weight of 1000 kg 1000 kg given y is equal to, that is a Young's modulus 12.5 into 10 to the power of 11 times per square centimeter. Then read the question carefully. What is the percentage increase in the length of a wire of diameter 12.5 millimeter? So the diameter is given, that is a 12.5 millimeter stretched by a weight. So that is the weight is equal to 1000 kg. With y, that is a Young's modulus, y is equal to 12.5 into 10 to the power of 11. So here to find out the change in length, that is what is the original length? Original length to the change in length. So to find out the ratio of the change in length to the original length, so consider that is a change in length to the original length is equal to, we know that the related formula is y is equal to Young's modulus, y is equal to stress by strain. Stress is known as a force per unit area divided by change in length to the original length. This is the related formula, that is Young's modulus is equal to stress divided by strain, and the stress is in the normal stress, that is a force per unit area, and this is the change in length to the original length. Then here take the change in length to the one side, that is a delta L divided by L is equal to delta L divided by L is equal to F divided by, take this, F divided by A into Y. F divided by A into Y. So to find out the value of A, F is given, Y is given, and the area is not given, then find out the value of A. So area is equal to, here the area is not given directly. So first to find out the value of area, we know that area of a wire is equal to pi into r square. So here d is given, therefore d is given means this is equal to pi into d divided by 2. That is a radius is equal to diameter by 2. Therefore r square means d square divided by 2. Square, and this value becomes as a, that is a d square divided by 2. 2 into 2, that is a 4. So subtract the value is equal to pi 3.14, and diameter of the wire is given as a, the diameter is given as a 12.5 square divided by 4. The value is in a centimeter square. Then find out the value of area. F is equal to, F is given here, F is equal to here kg means just the value of a mass is given, then 1000 kg. Then if we want to find out F is equal to F into G. Therefore, 1000 into 9.8, substitute this value or find out, calculate this value, and we have got that value is in the form of a dynes, convert in the form of a Newton, and we have got 9.8 into 10 to the power of 4. So calculate this value. 9.8 into 10 to the power of 3. Then substitute the values in the given equation. That is 1000 into 1000. The 1000 is in the form of a kg. Next one, that kg into 9.8. That is equal to 980. Because that it is in the form of a centimeter. So convert this unit also in the form of a dynes. That is equal to 9.8 into 10 to the power of 4 dynes. Then substitute this value in this formula is equal to 9.8 into 10 to the power of 8. 9.8 into 10 to the power of 8 into 10 to the power of minus 11, or substitute the value of the area, that is a 5 divided by 4 into, that is a 12.5 square into 12.5 is equal to, the answer is, calculate this value and find out the answer. The answer is in the form of it, that is a delta L by L. Both the unit are cancelled and we got the answer is 0.638 into 10 to the power of 8 minus 3. So this in the form of a percentage divided by 100 means 0.064 percentage. So in this step we calculate the answer, or that is a change in percentage length. So here in this type of question, what is the percentage? Percentage means find out the answer and divide it by 100. So percentage increase in length of a wire of a diameter 12.5 millimeter. Here the one wire is a given and the length of the wire is a 12.5 millimeter stretched by a weight. We see here, if that is a stretched by a weight is equal to m into g. Therefore, m into g is equal to 1000 kg. Next, here y, that is a Young's modulus is given. That is a y is equal to 12.5 into 10 to the power of 11. Then here, what is the related formula here? In the last class, we study about that. That is a Young's modulus y is equal to stress divided by strain. And we know that stress is equal to F by A divided by strain is equal to change in length to the original length. Then to find out here the question, to find out the change in length to the original length in the form of a percentage. Therefore take one side. Therefore delta L divided by L is equal to F by A divided by Y. So that is in the form of a delta L by L is equal to F divided by A by Y. Then find out the value. A is not given directly. So the diameter is given and we know that the area of a wire is equal to pi into r square. What is the meaning of r here? Diameter divided by 2. So first divide this value. D is equal to r by 2. Take in this type, r is equal to d by 2. Otherwise, substitute in this type. Then calculate the value of the area. Then substitute all the values in this formula and divide it by 100. Then we have got the answer in the form of a percentage. See the next one question. A cube of a side. Second one. A cube of side. A cube of side. 3 centimeter. 3 centimeter is subjected. Is subjected. Is subjected to shearing force. To shearing force. Shearing force. To shearing force. The top of a cube is the top of a the top of a cube is sheared through 0.012 centimeter with respect to bottom face to bottom face to bottom face with respect to bottom face if cube is made of if cube is made of cube is made of a material of shear modulus of shear modulus of shear modulus 2.1 into 10 to the power of 10 Newton meter square. Then find shearing strength. Then find shearing strength. Second, shearing stress. Third, force applied. So here, see the question carefully, find out the given values, substitute in the formula and find out the answer. A cube of a side means there is a side 3 centimeter. A cube of a side is a 3 centimeter. To subject a shearing force, the top of a cube is sheared through a 0.012. Means we know that this type of force is this type of stress is known as a shearing stress, and due to the shearing stress there is a due to this shearing stress that is also known as a tangential stress, and due to the tangential stress there is a displacement takes place, and that displacement is a 0.012. With respect to the bottom, if this displacement is a 0.012, only the upper surface is displaced in the tangential stress. Then bottom face of the cube is made of a material of a shear modulus 2.1 into 10 to the power of 10 Newton meter square. Then find the shearing strength and shearing stress. We know that shearing stress is equal to force per unit area is known as a shearing stress. Then first find out the shearing stress and shearing strain, that is a change in angular displacement. Find out the force. Then find out each value of the one sub questions. Then the first one, shearing strain, is equal to change in length divided by original length, and the change in length is 0.012, that is in the form of a centimeter, divided by original length of the tube is given, that is a 3 centimeter, is equal to that shearing strain delta L divided by L is equal to 0.04 centimeter. 0.004 centimeter. So here, see in the figure, due to the tangential stress, the upper face is displaced and that upper face is displaced with a 0.0012. The original length is a 3 centimeter. Then here to find out the shearing strain. What is the meaning of shearing strain here? Change in length to the original length is known as a shearing strain. Therefore, this value is given. Delta L is given 0.012. Original length is also given, that is a 3. So delta L by L is equal to 0.004 centimeter. This is also centimeter get cancelled, and the strain is a unitless quantity. So in this type we can find out the value of a change in length. See the second point. Second point, here the second point is the second point to find out the stress, shearing stress. Shearing stress. Shearing stress. We know that shearing stress is equal to shearing stress, that is a Young's modulus or the shearing modulus. Shearing modulus is equal to stress divided by strain. Stress divided by strain. That is a stress divided by strain. Stress is the force per unit area and the strain is defined as change in length to the original length. So to find out the force, to find out the shearing stress, take one side, stress is equal to shearing modulus into shearing modulus, that is a shear modulus into strain. So shear modulus is, so we know that stress is defined as the modulus of elasticity is equal to stress divided by strain. Therefore, stress is equal to shear modulus into strain. Cross multiply this value. If the cross multiply ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ಹೋಗಿ substitute ಮಾಡಿದ್ರೆ shear modulus is given. The given shear modulus is equal to shear modulus is equal to 0.04. That is a 2.1 into 10 to the power of 8. 2.1 into 10 to the power of 8. The value is given 10 into strain. We find out the value of a strain. That is a 0.004 into 0.004 is equal to cross multiply and find out multiply this value by using the calculator, and we got the answer 8.4 into 10 to the power of 7 Newton meter square. So in this type, the second sub question is also solved. The first one is the shearing strain. Shearing strain is equal to original length divided by change in length divided by original length. This 0.012 value given, 3 centimeter is also given. Divide this value, then we have got the shearing strain is equal to 0.04. Therefore, the next formula to find out the stress, we use the modulus of elasticity. Shearing modulus is equal to stress by strain. Here stress is equal to find out stress, cross multiply this shearing modulus into strain, substitute the value of a shearing modulus into strain. We got the answer 8.4 into 10 to the power of 7, that is a Newton meter square. Then next the third part, find out the third part. The third part is a shearing force. So we know that the stress is equal to The third point, third, that is the stress is equal to, this stress is known as a shearing stress. Shearing stress is equal to force per unit area. Therefore, force per unit area is equal to, here we want to find out the shearing force. Therefore, shearing force is equal to stress into area. Stress into area. So, stress, we can find out the stress. And the stress is equal to 8.4 into 10 to the power 7 into area. Area is equal to, area of this is all the sides are same, that is a 3. Means the area of a cube is equal to length into breadth. That is the area is equal to 3 into 3 square. Therefore, 3 into 3 square, that value is given in the centimeter. Convert that value in the meter. So we got this 3 into 10 to the power of 1. 3 into 10 to the power of 1 square. Otherwise, 30 into 30 square is equal to, the answer is 7.56 into 10 to the power of 4 Newton. The unit of a force is a Newton. So in this type we solve all the three parts in this question. That is equal to 7.56 into 10 to the power of 4 Newton. See the next question. A cube of 5 centimeter. A cube of 5 centimeter has its upper face displaced by 0.2 centimeter by a force of 8 Newton. Find the shear modulus. Stress and strain. Find out the shear modulus, stress and strain. So read the question. A cube of a 5 centimeter. There is again a cube is a given of 5 centimeter, means its side is a 5 centimeter. Upper force is a displaced by 0.2 centimeter. Means this displacement due to the inertial stress is a 0.2 centimeter by a force of a 8 Newton. Means F is equal to 8 Newton. Find the shear modulus, stress and strain. We know that shearing modulus is equal to stress divided by strain. And stress is defined as the force divided by area. Then find out the first value. That is the stress is equal to shear stress is equal to the first part answer. Shear stress is equal to F divided by 8. Where F is given 8 Newton divided by area. Area is equal to 5. 5 into 5 square. That is equal to 5. The value is in the form of a centimeter. Convert in the form of a meter. That is a 5 divided by 10. Means 5 into 10 to the power of minus 2 is equal to, convert this value, 5 into 5, that is equal to 25 into 10 to the power of minus 2 minus 4 meters square. So shearing stress is equal to force by area, and the answer is 3200 Newton per meter square. So use always the SI units, and the SI unit for the stress is a force per unit area, and the unit for force is a Newton. Unit for the SI unit is a meter square. So in this step we calculate the shearing stress is equal to 3200 Newton meter square. Then see the second part. Find the shearing modulus, stress and strain. Find out the strain. Strain is equal to, we know that strain is equal to change in length divided by original length. So change in length is a 0.2 and the original length is given as a 5. So calculate this shearing strain divided by original length of 0.2 centimeter divided by 5 centimeter. So the answer is a 0.04 and this strain is a unitless quantity because of this centimeter get cancelled. So in this time we calculate the second part also. Then third part is shearing modulus. So third, shearing modulus. Because shearing modulus is a depend upon the stress and strain. Shearing modulus is equal to shearing stress divided by shearing strain is equal to shearing stress is equal to 3200 divided by 0.04. Therefore, 3200 divided by 0.04. So calculate this value. We got the answer 80 into 3, 80 into 10 to the power of 3. That is a Newton per meter square. Newton per meter square. The unit for force is a Newton and the unit for the area is a meter square. So in this type we calculate the shearing modulus also. So see the next one. A composite wire, a composite wire, a composite wire, a composite wire of material, of material, of material A and B, A and B are the lengths of, are the lengths of, are the lengths of, are the length of a composite wire of material A and B are of length of 3.2 meter, 3.2 meter and 2.4 meter, 2.4 meter and area and areas 1 centimeter square and 1 centimeter square, 1 centimeter square and 1 centimeter square. Area of both the wire is same respectively. If the extension observed, if the extension observed if the extension observed is 1.2 millimeter, is 1.2 millimeter, find the force F. Find the force F. Find the force F. So here there are two wires are given. Two wires means a composite wire of material A and B are the length of 3.2 meter and 2.4 meter. So here consider the first one wire and the consider there is a second one wire are of the length of first wire is a 3.2 meter and the second wire is a 2.4 meter. So this is the original length of the wire, that is a L. If this is a L, there are two wires LA and LB. Length of a LA is equal to 3.2 meter. Length of the second wire, which is considered as a, this is a A, this is a B. Second wire is the length of a 2.4 meter. Then area of a first wire is area of cross section of a first wire, that is a A. Area of a first wire is equal to 1 centimeter square. Area of a B is equal to 1 centimeter square. Then if the extension observed is a 1.2 millimeter, that is a change in length is a 1.2 millimeter for the A and B, then the question is what is the force? To find out the force, we know that stress is equal to force per unit area. Then force is equal to stress into area. So to find out this, we consider the separate wires A and B and find out the separate values of the both values. So let the individual extension of the extension of the value of A, that is equal to extension of a delta A is equal to change in length LA is equal to force into original length of A divided by area of A into the Young's modulus of A. So this is a related formula. We know that Y is equal to stress divided by strain. Stress divided by strain. So stress is equal to F by A or change in length divided by original length. So here we want to find out the original length. So take this one side and all the values are other side. Let's substitute the given values and find out the change in length. Therefore, the original length is equal to this related formula for the A. Then find out the related formula for the B. Because there are two wires, so compare both the wires. This is equal to F into LB divided by area of a B into Young's modulus of a B. So this is the equation number 1 and this is the equation number 2. Then the original length of the change in length of both the wire is given as a 1.2. The change in wire of both the wire is the extension observed is a 1.2 millimeter. Means there is a in between both of these wires. There is an extension is observed. For example, if we consider the half part is a A and the second part is a B, in between the two wires there is an extension is observed, that is a delta L. So this extension is observed is equal to 1.2. Therefore, this delta LA plus delta LB, the extension in between both of them is a 1.2 millimeter. Then find out the value. Is equal to 1.2 is equal to L into A plus area of A first into Young's modulus of A plus length of B, original length of a B divided by area of a B into Young's modulus of a B is equal to 1.2 millimeter, that is equal to 1.2 into 10 to the power of 8 minus 4 meter. Substitute the values. 1.2 into 10 to the power of minus 4 is equal to length of A is given as a 3.2 divided by the area is given as a 10 to the power of minus 4 into 1.6 into 10 to the power of this value is given as a 10 to the power of 11. 1.6 into 10 to the power of 11 into modulus of A is given as a 1.6 into 10 to the power of 11. So substitute this value plus length of the B. Length of the B is given as a 2.4 divided by this area of cross section is given as a same 10 to the power of minus 4 into the epsilon modulus of B is given as a 2.4 into 10 to the power of 11. So simplify this equation and find out the force. That is, the force keep as it is, the F is keep as it is, and find out the value of F. So when we calculate this value, F into, when we solve this value, when we cross multiply and simplify this value, we have got 3 into 10 to the power of 8 minus 7 is equal to 1.2 into 10 to the power of minus 4. Therefore, F is equal to 400 Newton. So in this type, when we compare both the values, or when we comparing both the values, we calculate the force which is applied on the body. See the next one. A cube of 5 centimeters. A cube of 5 centimeters has its upper face has its upper face displaced by displaced by displaced by 0.2 centimeter 0.2 centimeter by a force of 8 Newton of 8 Newton. Find shear modulus. Find shear modulus, stress and strain. Stress and strain. So here, a cube of 5 centimeter has its upper face is a displaced by 0.2. So this is a cube whose side is a 5 centimeter. When the stress is applied, it is a displaced by 0.2 centimeter. So change in length is a 0.2, original length is a 5. Therefore, strain is equal to, and the force is 8 Newton, and area is given. So find out the shearing strain is equal to change in length divided by original length. So change in length is a 0.2 divided by original length is a 5. Therefore, the answer is 0.04. This is the first one. Second, when we find out the stress, or that stress is known as the shear stress. Shear stress is equal to force per unit area. The force is given 8 Newton, and the area of the cross section, one side is a 5. So 5 into 5 square is equal to 5 into 5, that is a 25 into 10 to the power of minus 4 is equal to, the answer is a 3200 Newton meter square. Then find out the shearing modulus. Shearing modulus is equal to stress stress divided by strain. Stress divided by strain. So stress is a 3200 divided by strain is equal to 0.04. Therefore, the answer is 80 into 10 to the power of 3. 80 into 10 to the power of 3 Newton per meter square. So in this time we simplify or we solve some questions of the chapter rigidity modulus of a mechanical properties of a solids.